Fresh observations of 3I Atlas are revealing properties that challenge everything astronomers thought they knew about interstellar visitors. While it was initially classified as a typical comet, new data suggests this object may be, deliberately concealing its true nature. Its perfect orbital alignment, suspicious timing, and anomalous behavior have sparked intense debates about whether we're witnessing natural phenomena or something far more extraordinary. The mounting evidence kind of forces us to confront an uncomfortable question. Could 3I Atlas represent our second encounter with extraterrestrial technology disguised as a harmless space rock? Fresh observations reveal mysteries. Recent spectroscopic analysis of 3I Atlas has uncovered anomalies that, honestly, defy conventional comet classification. Dr. Alan Fitzsimmons from Queen's University Belfast reported detecting unusual isotopic ratios in the object's outgassing that just don't match any known solar system materials. The object's infrared signature shows temperature variations that suggest internal heat sources, rather than simple solar warming. Most perplexing is the discovery of structured emissions, gas jets that appear to activate and deactivate in coordinated patterns rather than random sublimation. Dr. Michelle Bannister from the University of Canterbury noted that these emissions occur independently of the object's orientation toward the Sun, violating fundamental principles of cometary behavior. Radio telescope observations led by Dr. Avi Loeb detected low-frequency signals emanating from the object's vicinity, though their origin remains unexplained. The Hubble Space Telescope has captured images showing the object's surface reflectivity changes over time, suggesting either compositional variations or active surface modifications. These discoveries have, transformed 3I Atlas from a routine interstellar visitor into one of the most enigmatic objects ever studied. The scientific debate. The astronomical community finds itself honestly deeply divided over 3I Atlas's true nature, with heated debates emerging at major conferences worldwide. Dr. Robert Warwick from the University of Hawaii, who discovered the object, maintains it represents a conventional ice-rich comet from another star system, arguing that all observed anomalies fall within the range of natural variation. However, an increasing number of researchers question this interpretation. Dr. Marco Micheli from the European Space Agency points to the object's non-gravitational accelerations that don't correlate with visible outgassing patterns. Dr. Daryl Seligman from the University of Chicago noted that traditional comet models fail to explain the object's persistent activity at distances where water ice should remain frozen. Dr. Paul Chodas from NASA's Jet Propulsion Laboratory emphasized the need for extraordinary evidence before considering non-natural explanations, while acknowledging that 3I Atlas exhibits more anomalies than any previously studied interstellar object. The debate reflects broader tensions in astronomy about how to approach phenomena that challenge established paradigms, with careers and reputations at stake. The artificial origin hypothesis. Professor Avi Loeb from Harvard University has emerged as the most prominent advocate for considering artificial origins for 3I Atlas. Building on his controversial interpretation of Oumuamua, Loeb argues that the object displays multiple signatures consistent with extraterrestrial technology. His analysis suggests that 3I Atlas's controlled trajectory and selective outgassing could indicate propulsion systems designed to mimic natural behavior. Dr. Loeb proposes that the object might represent a reconnaissance probe using stealth technology to avoid detection while studying our solar system. He notes that the object's arrival timing coincides with increased human space activity, potentially suggesting deliberate surveillance. Dr. Sarah Seeger from MIT supports considering artificial hypotheses, arguing that dismissing anomalous observations without investigation represents scientific bias. Critics like Dr. Alan Harris from the German Aerospace Center argue that Loeb's interpretations require multiple untestable assumptions, violating Occam's razor principles. The hypothesis has sparked public fascination while creating professional controversy within the astronomical community. Dr. Loeb maintains that science progresses by, challenging conventional wisdom, even when conclusions prove uncomfortable or unpopular. Unusual detection pattern. The circumstances surrounding 3I Atlas's discovery raise, troubling questions about detection bias and possible concealment. Dr. Larry Deneau from the Atlas survey system revealed that the object had been present in archived images for over 6 months before automated systems flagged it as anomalous. Trajectory reconstruction by Dr. Davide Farnocchia shows that 3I Atlas entered our solar system in early 2024, remaining undetected despite passing relatively close to major asteroid surveys. Dr. Catalina Zuluaga from Harvard's Smithsonian Center for Astrophysics calculated that an object of 3I Atlas's size and brightness should have been detected months earlier by multiple survey systems. The late discovery becomes more suspicious when considering the object's approach vector. It arrived from a galactic direction with minimal stellar background, making it naturally difficult to detect against the sparse star field. Dr. Matthew Holman noted that this approach direction also corresponds to the galactic anti-center, where interstellar extinction is minimal, potentially indicating deliberate route planning. The detection pattern suggests either extraordinary coincidence or intentional concealment strategies. Suspicious orbital characteristics. Suspicious orbital characteristics. Statistical analysis of 3I Atlas's orbital parameters reveals improbable alignments that challenge natural origin theories. Dr. Fatih Namouni from Observatoire de la Côte d'Azur calculated that the object's near-perfect ecliptic plane alignment has only a 0.2% probability of occurring randomly for interstellar objects. More remarkably, 3I Atlas's trajectory creates close encounters with Venus, Mars, and Jupiter in a sequence that Dr. Kleomenis Tsiganis from Aristotle University determined has only a 0.005% probability of natural occurrence. The object's orbital inclination of just 1.3 degrees to the ecliptic means it travels through the most densely populated region of our solar system, maximizing potential gravitational interactions with planets. Dr. Alessandro Morbidelli noted that such alignments would be expected outcomes if the object were designed for systematic exploration of our planetary system. The timing of perihelion passage also coincides with optimal visibility from Earth, suggesting possible intentional revelation. These statistical anomalies compound the mystery surrounding 3I Atlas's true nature and purpose in our solar system. The hidden approach strategy. The timing of 3I Atlas's perihelion passage reveals what Dr. Avi Loeb describes as a cosmic blind spot strategy. Orbital mechanics calculations by Dr. Stephen Chesley from NASA JPL show that the object's closest solar approach occurs when Earth is positioned directly opposite in its orbit, creating a 7-month observation window with only 7% probability of natural occurrence. This positioning places the Sun between Earth and 3I Atlas during its most active phase, severely limiting ground-based observations and forcing reliance on space-based telescopes. Dr. Paul Wiegert from Western University noted that this configuration would be ideal for reconnaissance, allowing detailed study of Earth's orbital characteristics while minimizing detection risk. The object's outgassing pattern intensifies precisely when direct observation becomes difficult, potentially masking artificial activities behind natural phenomena. Dr. Loeb argues this represents sophisticated mission planning consistent with advanced intelligence. Critics counter that such interpretations reflect pattern recognition bias, but acknowledge the timing creates unprecedented observational challenges for determining the object's true nature. Scientific opposition and evidence. Mainstream astronomers have mounted vigorous opposition to artificial origin theories, citing fundamental physical and observational evidence. Dr. Olivier Hainaut from the European Southern Observatory argues that 3I Atlas's spectroscopic signature matches water ice sublimation, making artificial construction physically implausible. Size estimates derived from thermal infrared observations suggest the object measures 8 to 15 kilometers in diameter, far larger than any conceivable artificial probe. Dr. Bin Yang notes that constructing and propelling such a massive object would require energy resources exceeding the total output of entire stellar civilizations. Dr. Michael Ahearn's former colleague, Dr. Jessica Sunshine from the University of Maryland, emphasizes that all observed anomalous behaviors can be explained through exotic but natural processes involving pristine interstellar materials with unknown compositions. Dr. Alan Harris argues that selection bias influences interpretations. Humans naturally seek patterns and intelligence in random phenomena. However, artificial origin proponents counter that conventional explanations require increasingly improbable coincidences to account for the mounting statistical anomalies observed in 3I Atlas's behavior. Ancient origins and anomalous behavior. So, radiometric dating of 3I/Atlas's surface materials, based on spectroscopic analysis, suggests an age that's well over 7 billion years, meaning it actually predates the formation of our solar system. Dr. Dante Loretta from the University of Arizona pointed out that materials this old should, be heavily processed by cosmic ray bombardment. Yet 3I/Atlas shows these really pristine surface characteristics. The object's proximity to the Sun, about 1.1 astronomical units, should produce a prominent comet tail. But high-resolution imaging by Dr. Hermann Bohnhardt from Max Planck Institute reveals only subtle outgassing, which is honestly inconsistent with typical water ice behavior. Then thermal modeling by Dr. Yanga Fernandez from the University of Central Florida shows that 3I/Atlas's internal temperature distribution just doesn't match what we'd expect from solid ice, suggesting either a hollow internal structure or maybe even exotic materials. On top of that, Dr. Michael Kelly from the University of Maryland found that the object's rotation period stays remarkably stable, despite active outgassing that should, in theory, create torques and rotational changes. These structural anomalies really challenge our natural formation models and, well, they might even suggest engineered stability mechanisms. The stealth hypothesis. There's something called the stealth hypothesis. Advanced civilizations might actually use dark forest strategies to avoid detection while conducting interstellar reconnaissance, according to Dr. Avi Loeb's, pretty controversial stealth hypothesis. This theory, which is inspired by Liu Cixin's science fiction concepts, suggests that technological civilizations stay hidden to avoid, potentially hostile encounters with superior species. Dr. Jacob Haq-Misra from the Blue Marble Space Institute argues that artificial objects disguised as natural phenomena would be, honestly, the optimal surveillance strategy, allowing for detailed planetary analysis without revealing any technological capabilities. Dr. Loeb proposes that 3I/Atlas's mimicry of comet behavior could actually represent sophisticated camouflage technology, designed to avoid triggering defensive responses from emerging civilizations. The object's strategic positioning and timing would enable a comprehensive assessment of human technological progress and space capabilities. Now, Dr. Seth Shostak from the SETI Institute remains skeptical, noting that real stealth would involve complete concealment, not just partial mimicry. However, Dr. Loeb counters that perfect concealment actually prevents data collection, so a controlled revelation becomes a necessary compromise for effective reconnaissance missions. Lessons from Oumuamua. The 2017 Oumuamua encounter really serves as a cautionary tale about missed opportunities and, scientific conservatism. Dr. Robert Warwick, who actually discovered both objects, admits that Oumuamua's anomalous properties just weren't investigated enough, mostly due to limited observation time and, technological constraints. Dr. Abraham Loeb argues that the astronomical establishment's quick dismissal of artificial origin hypotheses for Oumuamua represents scientific bias, not rigorous analysis. 3I/Atlas gives us a second chance to properly investigate anomalous interstellar visitors, this time with better instruments and longer observation periods. Dr. Michelle Bannister emphasizes, the importance of systematic data collection instead of jumping to predetermined conclusions, and points out that both natural and artificial explanations deserve equal scientific scrutiny. Dr. Sarah Seeger from MIT argues that dismissing extraordinary possibilities without investigation actually violates fundamental scientific principles. The lesson from Oumuamua is pretty clear. Anomalous visitors require comprehensive investigation, not just reflexive categorization. Dr. Loeb maintains that future discoveries will vindicate careful analysis of seemingly impossible phenomena, regardless of what the ultimate explanation turns out to be. 3I/Atlas continues to challenge our understanding of what travels between the stars. Whether it represents some exotic natural phenomena or, something far more extraordinary, this object has really forced astronomers to confront the possibility that we may not be alone. The mounting statistical anomalies and honestly suspicious behaviors demand serious scientific investigation rather than just reflexive dismissal. As 3I/Atlas races toward its closest solar approach, we've got a limited window to unlock its secrets. Could this be our second encounter with extraterrestrial technology? Share your thoughts below. And if this cosmic mystery intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. For centuries, the moon has been a symbol of mystery and aspiration. But while pop culture and theorists debated what might be hiding on its shadowed surface, nations have been quietly racing to uncover its secrets. Recently, China made a discovery that bridges the gap between science fiction and reality, confirming that our celestial neighbor is far more dynamic and resource-rich than we ever imagined. This isn't just about rocks, it's about the future of humanity in space. Let's break down what they found and why it changes everything. Anomalous lunar structures. The notion of artificial structures on the moon has long been a fixture of speculative theories, often dismissed by mainstream science, but kept alive by intriguing images and anecdotal accounts. A key source of this speculation was the 1994 Clementine mission, a joint project between NASA and the U.S. Department of Defense. Officially, its goal was to map the lunar surface and test advanced sensors. However, the 1.8 million images it sent back contained visual oddities that have fueled debate for decades. On the moon's far side, often mistakenly called the dark side, some of these declassified images appear to show geometric shapes and unnatural-looking formations that enthusiasts claim are evidence of broken structures or alien junk. One famous image features what looks strikingly like a pyramid, with sharp angles and a distinct shadow that seems out of place among the moon's natural craters. Theorists argue that many of these images show signs of deliberate obfuscation or blurring, suggesting an attempt to hide what was actually photographed. While scientists largely attribute these anomalies to digital compression artifacts and the play of light and shadow on a complex surface, for many, the Clementine mission was a reconnaissance effort to gather intel on something that was already known to be there. Ancient astronaut connections. The belief in lunar structures is deeply intertwined with the ancient astronaut theory, which proposes that extraterrestrial beings visited Earth in antiquity and influenced human civilization. Proponents of this theory point to various pieces of disputed evidence as proof of a continued alien presence in our solar system. One of the most cited examples is an alleged black box audio recording from the Apollo 11 mission. In this supposed transcript, Neil Armstrong is claimed to have said, "Look at those convex structures down there," describing them in a way that implies they were dome-like and artificial. While the authenticity of this quote is widely rejected and considered UFO folklore, it taps into a powerful narrative of cosmic secrecy. This narrative is further bolstered by interpretations of ancient texts, like the Sumerian tablets, which describe beings called the Anunnaki. In these stories, a god figure takes his son to the moon and tells him to wear his eagle's mask, which theorists interpret as a breathing helmet. The idea is that these ancient gods were actually extraterrestrials with advanced technology, and their masks were the helmets needed to survive in harsh environments like the moon or Mars. This connects to countless pieces of ancient art, such as the Wandjina cave paintings in Australia, which depict figures that look uncannily like modern-day astronauts in bubble helmets. China's groundbreaking discovery. While theories about ancient aliens capture the imagination, China's lunar program has delivered concrete, game-changing discoveries grounded in hard science. The nation's crowning achievement was the Chang'e 5 mission, which in December 2020 successfully landed in the Oceanus Procellarum region, drilled into the lunar surface, and returned with 1,731 grams of fresh lunar soil and rock samples. This was the first time any nation had retrieved lunar material in over 44 years. After months of intensive study by Chinese scientists, a landmark announcement was made in 2022, the discovery of an entirely new lunar mineral, named Change Site Y. This tiny, transparent columnar crystal was a monumental find, making China the third country in history, after the United States and the former Soviet Union, to discover a new mineral on the moon. But the revelations didn't stop there. Analysis of the soil samples also confirmed the presence of water, but in a completely unexpected form. Scientists found water molecules locked within tiny, soil-embedded glass beads, which were formed during the violent high-heat events of asteroid impacts. This discovery was revolutionary, proving that water on the moon was not just confined to ice at the poles, but was more widely distributed across its surface. Revolutionary implications. The confirmation of water within lunar soil has staggering implications for the future of space exploration. It is honestly the key that unlocks the concept of in situ resource utilization, or ISRU, which means the ability to live off the land. For decades, The logistics of a permanent human presence on the moon were, well, deemed nearly impossible due to the prohibitive cost of launching every necessary resource, water, air, fuel, from Earth. China's discovery changes this equation entirely. The water trapped in these glass beads, while minuscule in each particle, could amount to as much as 270 billion metric tons across the entire moon. With the right technology, rovers could heat the lunar soil to release this water vapor, which could then be collected and stored. This water could be used for drinking and agriculture in a future lunar base. More importantly, through a process called electrolysis, it can be split into its component elements, hydrogen and oxygen. This provides a source of breathable air for astronauts and, critically, the two primary components of modern rocket fuel. The moon could effectively become a celestial gas station, where spacecraft launching from Earth can refuel for missions to Mars and beyond. This dramatically reduces the mass and cost of deep space missions, making the sustained exploration of our solar system a far more achievable reality. The Chang'e program evolution. China's triumph with Chang'e 5 was not an overnight success, but the result of a meticulously planned multi-decade endeavor known as the Chinese Lunar Exploration Program. The program, named after the Chinese moon goddess Chang'e, unfolded in a series of logical, increasingly complex steps. It began with Chang'e 1, launched in 2007, and Chang'e 2, launched in 2010. These were two orbital missions that mapped the lunar surface in high resolution and scouted for future landing sites. The next phase involved landing on the moon. In 2013, the Chang'e 3 mission successfully touched down, deploying the U-2 rover and making China the third country to perform a lunar soft landing. Then, in a stunning display of technical prowess, the Chang'e 4 mission in 2019 achieved what no other space agency had ever attempted, a successful landing on the moon's far side. This historic feat required a dedicated relay satellite to maintain communication with Earth. The program's third phase culminated with Chang'e 5 in 2020. This mission showcased China's mastery of incredibly complex maneuvers, including an automated launch from the lunar surface and a robotic rendezvous, and docking in lunar orbit to transfer the samples for their return journey. This steady, step-by-step evolution has, firmly established China as a top-tier space power. Resource revolution on the moon. The Chang'e 5 samples have kickstarted a complete re-evaluation of the moon's economic and strategic value, transforming it from a barren wasteland into a treasure trove of vital resources. The discovery of Change Site Y was significant not just because it was a new mineral, but because it is a phosphate mineral that contains helium-3. On Earth, helium-3 is incredibly rare, but it is abundant on the moon, having been deposited on the lunar surface by solar winds over billions of years. Scientists believe helium-3 is the perfect fuel for nuclear fusion, the same process that powers the sun. A fusion reactor running on helium-3 could provide a safe, clean, and virtually limitless source of energy, without the long-lived radioactive waste produced by current nuclear fission reactors. The ability to mine helium-3 could revolutionize energy production both on the moon and back on Earth. Beyond helium-3 and water, the lunar regolith is also rich in rare Earth elements, like neodymium, lanthanum, and yttrium, which are essential components in everything from smartphones and electric vehicles to advanced military technology. The moon therefore represents a potential solution to Earth's dwindling resources and could become the cornerstone of an interplanetary supply chain. Future lunar colonization. With confirmed access to water for life support, hydrogen and oxygen for rocket fuel, and helium-3 for energy, the dream of establishing a permanent human colony on the moon has officially moved from the realm of science fiction into the strategic plans of spacefaring nations. The ability to use local resources is, honestly, the key to sustainability. In March 2021, China and Russia capitalized on this new potential by signing a memorandum of understanding to jointly construct the International Lunar Research Station. This ambitious project envisions a permanent, autonomously operated base located at the moon's south pole, a region believed to hold large deposits of water ice in its shadowed craters. The ILRS is planned to be operational by the mid-2030s and will be a complex for scientific research, resource extraction, and technology verification. It will serve as a testing ground for the technologies needed to support human life in deep space, and act as a crucial staging point for future crewed missions to Mars. China has even floated the idea of building a nuclear power plant on the moon by 2028 to provide the substantial energy required for the base's long-term operations, demonstrating a clear and determined vision for lunar colonization. Lunar resources, the new gold rush. The scientific confirmation of vast and valuable resources on the moon has, ignited a 21st century gold rush, sparking some pretty intense geopolitical competition for control over lunar territory and its riches. The economic implications here are just enormous. The ability to mine water, helium-3 and rare earth elements could, honestly, create entirely new industries and shift the global balance of power. This has turned the moon's south pole into probably the most desirable real estate in the entire solar system, as its permanently shadowed craters are thought to contain massive, accessible deposits of water ice. However, this frantic race to the moon is unfolding in, a legal gray area. The 1967 Outer Space Treaty, which is basically the foundational document of space law, clearly states that no nation can claim sovereignty over any part of a celestial body, but the treaty is, pretty silent and ambiguous on the issue of resource extraction by commercial or state entities. It does not explicitly prohibit mining, nor does it establish a clear framework for who owns the resources that are extracted. This legal vacuum is creating a high-stakes environment where nations are rushing to establish a presence, a sort of facts-on-the-ground precedent, to bolster future claims to lunar resources. International space race. The modern space race is, a multipolar and multifaceted competition, and it's really starkly different from the old two-nation Cold War rivalry. In one corner stands the United States, which is pursuing a return to the moon through NASA's Artemis program. The program's stated goals are to land the first woman and first person of color on the lunar surface, and to establish a sustainable, long-term human presence. A key feature of the Artemis program is its deep reliance on commercial partnerships. Instead of building all its own hardware, NASA has contracted private companies like SpaceX to develop the Starship human landing system and Blue Origin to build a second lander. This public-private model aims to foster innovation and reduce costs by leveraging the dynamism of the commercial space industry. This approach is actually codified in the Artemis Accords, a set of non-binding principles for safe and transparent lunar exploration. The accords have been signed by dozens of countries, creating a pretty broad US-led coalition. This collaborative yet commercially driven strategy represents a fundamentally different philosophy from the state-controlled programs of its main rivals, and it's really setting the stage for a new era of exploration, defined by competing models of international cooperation. Competition between China, US, and other nations. The new race to the moon is honestly increasingly defined by two major competing blocks. On one side is the US-led Artemis Accords, which brings together established space powers like Japan, Canada, and the European Space Agency, along with emerging space nations, under a common framework for lunar governance. On the other side is the China-Russia Alliance for the International Lunar Research Station. While this partnership is currently smaller, it is actively recruiting other nations, with countries like Pakistan, the UAE, and Venezuela having signed on. This creates a clear geopolitical divide, extending terrestrial rivalries right into the celestial sphere. However, it's not strictly a bipolar race. Other independent players are making significant strides. India's space agency, ISRO, achieved a major triumph in 2023 with its Chandrayaan-3 mission, which successfully landed a rover near the lunar South Pole, a historic first. This really demonstrated India's growing capabilities and its intent to be a key player in lunar exploration. The landscape is a complex tapestry of national ambition, commercial interests, and strategic alliances, where intense competition is the primary driver of innovation, but the immense challenges of space may ultimately necessitate cooperation between these rival factions for humanity to truly establish a permanent foothold on the moon and beyond. From mysterious anomalies to game-changing mineral discoveries, the moon has once again captured the world's imagination. It's no longer just a silent, barren world, but a frontier of immense scientific and strategic importance. China's recent findings have accelerated a new era of exploration, pushing humanity to answer some pretty profound questions about our past and our future in the cosmos. So, what do you think is hiding on the moon? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of science and technology. Thanks for watching Future Facts. Since 2016, NASA's Juno spacecraft has been peering beneath Jupiter's beautiful but deceptive cloud layers, uncovering secrets that challenge everything we thought we knew about the solar system's largest planet. What mission scientists discovered deep within Jupiter's atmosphere defies explanation. A mysterious central storm system unlike anything found elsewhere in the universe. The data streaming back from Juno's sensors reveals that Jupiter isn't just a giant ball of gas, but a world harboring terrifying forces and unexplained phenomena that could reshape our understanding of planetary formation itself. The mysterious central storm discovery. Deep within Jupiter's core lies a discovery that has left planetary scientists speechless. Juno's microwave radiometer penetrated 350 kilometers below the cloud tops and detected what appears to be a permanent central vortex spanning thousands of kilometers across. Unlike the Great Red Spot or other visible storms, this deep atmospheric feature shows no signs of the typical cyclonic rotation patterns found elsewhere on Jupiter. Dr. Scott Bolton, Juno's principal investigator, describes it as a hurricane frozen in time, a massive atmospheric disturbance that appears to have remained unchanged for potentially millions of years. The storm system generates electromagnetic pulses that interfere with Juno's instruments, creating data gaps that suggest something far more complex than simple atmospheric circulation. Most disturbing is the storm's perfect geometric structure. It forms concentric rings with mathematical precision that defies known meteorological processes. The central vortex appears to extend all the way down to Jupiter's metallic hydrogen core, creating a direct channel between the planet's surface storms and its deepest interior regions. The beginning of the mission. Juno launched on August 5, 2011, beginning a 5-year journey to reach Jupiter and unlock the secrets of the solar system's formation. The spacecraft was designed with a unique polar orbit that would allow it to study Jupiter's interior structure without being destroyed by the planet's deadly radiation belts. Lockheed Martin built the titanium-armored probe to withstand radiation levels 1,000 times stronger than those that would kill a human instantly. The mission's primary goals included mapping Jupiter's gravitational field, studying its atmospheric composition, and determining whether the planet has a solid core. NASA scientists equipped Juno with 9 sophisticated instruments, including a JunoCam for public outreach and scientific imaging. The spacecraft's 3 massive solar panels make it the most distant solar-powered probe ever launched, generating electricity from sunlight 25 times weaker than that reaching Earth. After traveling 2.8 billion kilometers, Juno successfully entered Jupiter's orbit on July 4, 2016, beginning what would become one of the most revolutionary planetary exploration missions in history. Jupiter is the world of chaos. Jupiter's atmosphere operates on a scale of violence that dwarfs anything found on Earth. Wind speeds reach 640 kilometers per hour, nearly twice as fast as the strongest hurricanes ever recorded on our planet. The atmospheric bands that give Jupiter its distinctive striped appearance are actually jet streams containing more energy than all of Earth's weather systems combined. Dr. Andy Ingersoll from Caltech discovered that Jupiter's storms can maintain their intensity for centuries, with some features persisting longer than human civilization has existed. The planet's rapid 9.9-hour rotation creates Coriolis forces so powerful they tear apart smaller storm systems while strengthening larger ones. Temperature variations between different atmospheric layers create vertical wind shears that would instantly destroy any Earth-based aircraft. Most shocking is the discovery of thermal towers, massive columns of superheated gas that erupt from deep within Jupiter's interior, carrying energy equivalent to multiple nuclear explosions every second. These thermal plumes create the pop-up clouds that appear suddenly at atmospheric boundaries, representing eruptions of material from depths of over 100 kilometers below the visible cloud deck. Io, the volcanic moon. Io, Jupiter's innermost large moon, represents a world that's literally being torn apart by gravitational forces. This sulfur-covered hellscape hosts over 400 active volcanoes, making it, well, the most geologically active body in the solar system. Dr. Rosalie Lopez from JPL has cataloged volcanic eruptions on Io that blast material 500 kilometers into space. That's high enough to reach from Earth's surface all the way up to the International Space Station. Jupiter's immense gravity, along with the gravitational tugging from Europa and Ganymede, creates tidal flexing that generates enough internal heat to actually melt Io's rocky interior. The moon's volcanic activity pumps 1 ton of material per second into Jupiter's magnetosphere, creating a plasma torus that, feeds the planet's radiation belts. Some of Io's volcanic plumes reach temperatures of 1,800 degrees Celsius, that's hot enough to melt copper, while ejecting sulfur dioxide snow that gives the moon its distinctive yellow and orange appearance. Juno's observations reveal that Io's volcanic activity directly influences Jupiter's auroras, creating an electrical connection between the moon and the planet that generates 5 million amperes of current flowing through space. Research on Jupiter's magnetic field. Jupiter's magnetic field represents one of the most powerful and complex magnetic environments in the solar system. Generated by electrical currents in the planet's metallic hydrogen core, the field extends over 1 million kilometers from Jupiter's surface, so large it would appear 5 times the size of the full moon if you could actually see it from Earth. Dr. Jack Connerny from NASA Goddard leads research showing that Jupiter's magnetosphere contains enough energy to power human civilization for millions of years. The magnetic field traps charged particles from the solar wind, creating radiation belts that are 10,000 times more intense than Earth's Van Allen belts. Most mysteriously, Juno discovered that Jupiter's magnetic field has an asymmetric structure with a distinct northern magnetic anomaly, a feature that really shouldn't exist according to traditional magnetic field models. The field appears to be generated by shallow flows in the metallic hydrogen layer, rather than by deep convection processes as previously assumed. This discovery suggests that Jupiter's interior structure is far more complex than simple models predict, with multiple layers of conducting fluids creating a dynamo system unlike any other planet we've studied. Juno mission peaks under Jupiter's surface. Juno's gravitational measurements have, honestly, revolutionized our understanding of Jupiter's internal structure by revealing what actually lies beneath those swirling clouds. The spacecraft's precision tracking detected gravitational anomalies indicating that Jupiter has a fuzzy or dilute core, rather than the distinct, solid center that scientists had expected. Dr. Tristan Guillot from Observatoire de la Côte d'Azur analyzed the data, showing that heavy elements are mixed throughout Jupiter's interior instead of being concentrated in a central core. This partially dissolved core extends outward for thousands of kilometers, containing between 7 and 25 Earth masses of rocky material distributed through the planet's metallic hydrogen region. The discovery suggests that Jupiter suffered a massive collision early in its formation, an impact so violent it scattered core material throughout the planet's interior. Microwave soundings reveal that Jupiter's ammonia concentration varies dramatically with depth, creating distinct atmospheric layers that trap and release gases in complex cycles. The planet's interior rotates as a solid body down to depths of 3,000 kilometers, below which differential rotation creates shearing forces that generate the observed magnetic field patterns. Jupiter's formation and composition. Jupiter's formation story has been, completely rewritten by Juno's discoveries about the planet's water content and internal structure. Dr. Chung Lee from UC Berkeley found that Jupiter actually contains about 3 times more water than expected, with concentrations that, interestingly, vary dramatically between different atmospheric regions. The uneven water distribution suggests that Jupiter formed through core accretion rather than gravitational collapse, meaning it slowly built up from solid materials before capturing gas from the solar nebula. Heavy elements make up between 3 and 9% of Jupiter's total mass, far more than previous models predicted, which indicates the planet accumulated significant amounts of rocky planetesimals during its formation. The discovery of phosphine gas in Jupiter's upper atmosphere provides evidence of vertical mixing, which transports material from deep interior regions where the gas forms under extreme pressure. Isotopic ratios measured by Juno even suggest that Jupiter migrated inward toward the Sun during its early history before moving back to its current position, a grand tack model that helps explain the architecture of our entire solar system. This migration scattered asteroid belt material and prevented super-Earth formation in the inner solar system. Jupiter as Earth's protector. So, Jupiter actually serves as Earth's gravitational guardian, deflecting potentially catastrophic asteroids and comets away from the inner solar system. According to computer simulations by Dr. Kevin Grazier, without Jupiter's immense gravity, Earth would be bombarded by impacts 1,000 times more frequently, making complex life, virtually impossible. The planet's orbital resonances, create asteroid families and gaps in the asteroid belt, which prevents small rocky bodies from spiraling toward Earth. During the early solar system, Jupiter's migration scattered icy comets from the Kuiper belt, and many of those actually delivered the water that fills Earth's oceans today. The planet also captures interstellar objects entering our solar system, like asteroids from other star systems that could otherwise pose unpredictable threats to Earth. Recent studies show that Jupiter's gravitational influence extends beyond Neptune's orbit, affecting the trajectories of long-period comets that originate in the Oort cloud. But here's the thing. Jupiter occasionally sends objects toward Earth as well, since its gravity can perturb comet orbits and redirect them into the inner solar system. So, this double-edged protection means Jupiter both shields and sometimes threatens Earth, maintaining a delicate balance that has allowed life to flourish on our planet. The Great Red Spot Mystery. The Great Red Spot has been shrinking for over 150 years, and Juno's close-up observations are finally revealing why this iconic storm may be slowly dying. Dr. Amy Simon from NASA Goddard discovered that the storm has lost 50% of its width since the 1800s, and it continues shrinking at an accelerating rate. Juno's infrared spectrometer found that the Great Red Spot extends about 300 kilometers deep into Jupiter's atmosphere, much deeper than any hurricane on Earth, but actually shallower than expected for such a long-lived feature. The storm's distinctive red color comes from complex organic compounds created when ammonia and hydrogen sulfide are exposed to ultraviolet radiation from the sun. Wind measurements show that the storm's outer edges rotate faster than its center, creating shearing forces that may be gradually tearing the vortex apart. Most mysteriously, the Great Red Spot sometimes changes color from deep red to pale orange, which suggests chemical reactions are happening within the storm system. Computer models suggest the storm may completely disappear within the next 50 years, ending a 300-year-old atmospheric feature that has served as Jupiter's most recognizable landmark. The Atmospheric Rivers Discovery. Juno's microwave radiometer uncovered a previously unknown feature that might be Jupiter's most important atmospheric discovery: massive atmospheric rivers flowing beneath the visible cloud layers. These invisible currents transport ammonia and water vapor across thousands of kilometers, working like conveyor belts that redistribute heat and chemicals throughout Jupiter's atmosphere. Dr. Karen Dewar from the Weizmann Institute identified these deep atmospheric streams using radio emissions that can penetrate Jupiter's thick clouds. The atmospheric rivers flow at depths of 100 to 200 kilometers below the surface, carrying 10 times more material than all of Earth's atmospheric circulation combined. These hidden currents help explain how Jupiter's bands maintain their distinct chemical compositions, even with all the planet's turbulent mixing. The rivers seem to connect polar cyclones with equatorial jet streams, creating a global circulation pattern that operates independently of surface weather. Most remarkably, these deep atmospheric flows may be directly connected to Jupiter's metallic hydrogen core, suggesting that the planet's weather systems extend all the way to its center. This discovery really shows that Jupiter's atmosphere is a three-dimensional system, way more complex than the simple layered structure scientists used to assume. Juno's revelations about Jupiter have, honestly, shattered our understanding of the solar system's giant. From mysterious central storms to atmospheric rivers flowing beneath the clouds, Jupiter harbors secrets that challenge fundamental theories about planetary formation. The discovery that our cosmic protector contains a partially dissolved core and complex interior dynamics proves there's still so much to learn about our celestial neighborhood. So, which Jupiter mystery fascinated you the most? Share your thoughts below. If you enjoyed uncovering these incredible planetary secrets, go ahead and hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more mind-blowing cosmic discoveries. In a groundbreaking event, the James Webb Space Telescope has captured what many call the first real image of the interstellar visitor 3Y Atlas. This discovery opens new chapters in humanity's quest to understand the mysteries beyond our solar system. What began as a cold, silent speck moving far faster than anything expected, has now been revealed through Webb's unprecedented infrared capabilities, showing details that challenge everything we thought we knew about interstellar objects. The flicker in the data. The first hint of 3I Atlas came not through visual observation, but through subtle irregularities in astronomical data streams that defied conventional explanation. Ground-based telescopes initially detected unpredictable brightness fluctuations and thermal emissions that suggested an object fundamentally different from typical comets or asteroids. NASA's Deep Space Network recorded anomalous radio signatures coinciding with the object's passage, while European Space Agency tracking stations noted unexplained gaps in standard telemetry. These data inconsistencies formed a pattern that Dr. Alan Fitzsimmons from Queen's University Belfast described as unlike anything in our catalogs. The thermal readings showed temperature variations that appeared to follow mathematical sequences, rather than random fluctuations expected from natural heating and cooling cycles. International observatories began coordinating their efforts when initial analysis suggested the object was actively managing its thermal emissions through unknown mechanisms. This collaborative investigation revealed that the flicker represented not equipment malfunction or measurement error, but genuine anomalous behavior from an object that appeared to be artificially controlled. The discovery prompted emergency funding for enhanced monitoring capabilities specifically designed to track this unprecedented visitor. 152,000 mph from the void. 3I Atlas races through space at a staggering velocity of approximately 152,000 miles per hour, relative to our solar system, far exceeding the typical speeds of natural debris ejected from stellar systems. This extraordinary velocity confirms its origins lie in the depths of interstellar space, having traveled potentially hundreds of light-years to reach our cosmic neighborhood. Dr. Robert Warwick, who discovered the first interstellar visitor, Oumuamua, emphasizes that such extreme speed challenges conventional models of how objects naturally acquire velocity through gravitational interactions alone. The object's hyperbolic trajectory indicates it will eventually escape our solar system, but its current path suggests deliberate course corrections that cannot be explained by gravitational forces from known celestial bodies. Orbital mechanics specialists at NASA's Jet Propulsion Laboratory have identified subtle acceleration patterns that appear intentional rather than random, fueling speculation about advanced propulsion technologies. Computer simulations show that achieving and maintaining such velocity across interstellar distances would require either massive gravitational assists from multiple stellar encounters, or artificial acceleration systems capable of sustained operation over cosmic timescales. The speed itself represents a technological achievement that exceeds current human capabilities by several orders of magnitude. 3 visitors, 7 years. Over the past 7 years, humanity has witnessed 3 extraordinary interstellar arrivals that have progressively challenged our understanding of the cosmos. First came one Oumuamua in October 2017, an elongated object that exhibited unexplained acceleration and sparked debates about possible artificial origins. 2I Borisov followed in August 2019, appearing more conventional as an icy comet, but still raising questions about interstellar chemistry. Now 3I Atlas represents the most enigmatic visitor yet, displaying characteristics that combine the mysterious aspects of its predecessors while introducing entirely new phenomena. Dr. Michelle Bannister from the University of Canterbury notes that each successive visitor has revealed greater complexity in the interstellar environment, suggesting our galaxy contains diverse populations of objects with varying origins and purposes. Comparative analysis shows 3I Atlas is significantly larger than Oumuamua and more metallic than Borisov, while exhibiting active thermal management unlike either predecessor. Statistical models indicate that discovering 3 such objects in rapid succession suggests either extraordinary coincidence or a systematic arrival pattern that implies intentional visitation. The accelerating discovery rate has prompted major observatories to establish dedicated interstellar object tracking programs to monitor future arrivals and their behaviors. James Webb's metallic discovery. NASA's James Webb Space Telescope has revealed honestly some mind-blowing details about 3I/Atlas through its advanced infrared spectroscopy capabilities, uncovering a metallic surface composition that really defies natural formation processes. Dr. Heidi Hamel, who serves as Webb's interdisciplinary scientist, led the spectroscopic analysis that identified titanium-aluminum alloys and other engineered materials, which are totally inconsistent with what we usually see in asteroids or comets. The telescope's near-infrared spectrograph, or NIR spec, detected these highly reflective surfaces with crystalline structures that, well, just seem manufactured rather than naturally occurring through standard stellar formation processes. Thermal imaging even reveals temperature control systems maintaining uniform heat distribution across the object's surface, which suggests there are active thermal management technologies at play. Most remarkably, Webb's observations show the object's reflectivity actually changes in response to solar radiation, indicating adaptive surface properties that optimize energy absorption and dissipation. Materials scientists analyzing the spectral data report, almost unbelievably, impossible purity levels for the detected metals, requiring advanced refining techniques that are way beyond current human capabilities. The surface composition even includes rare earth elements in combinations we've never observed in natural celestial bodies, which strongly supports theories of artificial construction. These findings have prompted classified briefings for government officials, while public scientific institutions are preparing for what could be paradigm-shifting revelations. The machine that steers itself. Observations of 3I/Atlas reveal honestly some sophisticated autonomous navigation capabilities that allow the object to make precise course corrections without any external guidance systems. Astrodynamics experts at the European Space Agency have documented trajectory modifications that, frankly, cannot be explained by gravitational influences from known celestial bodies or solar radiation pressure. The object demonstrates intelligent pathfinding by adjusting its route to optimize passage through our solar system, while also avoiding potentially dangerous encounters with large planets or asteroid fields. Dr. Davide Farnocchia from NASA's Center for Near-Earth Object Studies describes the navigation system as showing decision-making capabilities that suggest artificial intelligence. Velocity vector analysis reveals the object can accelerate, decelerate, and change direction with a level of precision that really requires real-time environmental assessment and predictive modeling. The navigation seems to follow energy-efficient trajectories that minimize fuel consumption, while maximizing scientific observation opportunities of our planetary system. Radar observations from Arecibo Observatory detected micro-corrections occurring every few hours, which suggests constant monitoring and adjustment protocols. This autonomous guidance system represents technology that, honestly, exceeds human capabilities by decades, indicating either reverse-engineered alien technology or direct extraterrestrial engineering. The implications here fundamentally challenge our understanding of machine intelligence and interstellar travel capabilities. Information blackout. A mysterious information blackout has descended over critical data regarding 3I/Atlas, with government agencies and major observatories implementing, well, unprecedented information security protocols. Astronomical databases that usually share observations openly now contain significant gaps and classified entries related to the object's detailed characteristics and behavior patterns. Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics reports that, honestly, normally transparent scientific institutions have become unusually secretive about ongoing observations and analysis results. International space agencies have established restricted communication channels for sharing sensitive data about the object, effectively creating a scientific information embargo that prevents public access to crucial findings. Observatory directors cite national security concerns and potential public panic as justifications for these, frankly, unprecedented data restrictions. Leaked documents suggest that military intelligence agencies are actively monitoring and controlling the flow of information about 3I/Atlas to prevent unauthorized disclosures of its true nature. Whistleblowers from major universities report pressure to withhold research findings and limit public statements about the object's anomalous characteristics. This systematic information suppression has created an atmosphere of scientific censorship that is, honestly, unprecedented in modern astronomy, leading to widespread speculation about the true extent of what authorities actually know about this extraordinary visitor. Adaptive shielding technology. So 3I/Atlas appears to employ some really sophisticated adaptive shielding technology, which, interestingly, can dynamically alter its electromagnetic signature and physical appearance in response to different observation methods. Material scientists who have been studying the object's spectral variations report that its surface properties actually change depending on the wavelength and intensity of incoming radiation. Dr. Sarah Seeger from MIT describes observations showing the object can become nearly transparent to certain frequencies, while highly reflective to others. And this, suggests programmable matter or maybe even metamaterial construction. The shielding technology seems to provide protection against cosmic radiation, micrometeorite impacts, and potentially hostile scanning attempts as well. Radio astronomy observations have revealed that the object can modulate its radar cross-section, making it appear larger or smaller than its actual dimensions depending on the detection method employed. Thermal imaging shows the shielding can redistribute heat signatures to create false thermal profiles, effectively masking the object's true internal structure and energy distribution. Quantum physicists, meanwhile, theorize the technology might utilize field manipulation or controlled phase transitions in exotic matter to achieve these adaptive properties. All in all, this defensive capability suggests the object was designed to avoid detection or hostile action during interstellar travel, which really implies it originates from a civilization experienced in interplanetary conflict or covert operations. The Ancient Probe Network. Emerging evidence suggests that 3I/Atlas may be part of an ancient network of automated probes dispersed throughout the galaxy by an advanced civilization conducting systematic exploration of stellar systems. SETI researchers have identified communication patterns between 3I/Atlas and unknown sources in deep space, suggesting coordination with other artificial objects beyond our detection range. Dr. Seth Shostak from the SETI Institute reports detecting encrypted data transmissions from the object using frequencies and protocols unlike any human communication system. Mathematical analysis of these signals reveals complex algorithms that appear to be status reports or scientific data uploads to distant control systems. Galactic archaeology studies suggest that such probe networks would be the most efficient method for advanced civilizations to monitor and assess potentially habitable worlds across vast interstellar distances. Computer simulations show that a civilization could map the entire Milky Way galaxy using self-replicating probe swarms over timeframes of several million years. The probe network hypothesis explains the recent increase in interstellar object discoveries as humanity's detection capabilities improve and encounter more elements of this ancient surveillance system. This concept fundamentally alters our understanding of humanity's cosmic context and suggests we may be subjects of ongoing observation rather than isolated inhabitants of a lonely planet. Prime numbers in heat signatures. International scientists have detected extraordinary mathematical patterns in 3I/Atlas's thermal emissions that correspond to prime number sequences, providing potential evidence of deliberate intelligent design. Dr. Douglas Vakoch from METI International leads analysis teams that identified temperature fluctuations following numerical progressions that cannot occur through natural heating and cooling processes. The thermal patterns emit prime numbers in sequence, 2, 3, 5, 7, 11, 13. Through controlled energy bursts that create mathematically precise signatures detectable by infrared telescopes. Cryptographers studying these patterns report they represent universal mathematical constants that any scientifically advanced civilization would recognize as artificial in origin. Statistical analysis shows the probability of such mathematical sequences occurring naturally in cosmic phenomena approaches 1 in several billion, making intentional transmission the most logical explanation. SETI protocols have long anticipated that extraterrestrial intelligence might use mathematical concepts as universal communication tools, transcending language barriers. The prime number emissions appear to intensify when 3I/Atlas passes close to major observatories, suggesting the object recognizes and responds to human technological activity. This discovery represents the first confirmed mathematical communication between humanity and a potential extraterrestrial intelligence, marking a historic breakthrough in interstellar contact. We were never the observers. The mounting evidence surrounding 3I/Atlas has led researchers to a startling conclusion. Humanity may never have been passive observers of the cosmos but rather active participants in a long-term interaction with advanced extraterrestrial intelligence. Dr. Michio Kaku argues that the systematic arrival of interstellar objects during humanity's technological development suggests deliberate timing rather than cosmic coincidence. Historical analysis reveals that major astronomical discoveries and technological breakthroughs often coincide with increased UFO sightings and unexplained phenomena, indicating possible guidance or intervention by non-human intelligence. Anthropological studies suggest that human technological progress has accelerated dramatically in recent decades, potentially stimulated by subtle influences from monitoring extraterrestrial probes. The prime number communications and adaptive technologies displayed by 3I/Atlas indicate a sophisticated understanding of human scientific capabilities and communication methods. Philosophers of science propose that humanity's rapid advancement from primitive agriculture to space exploration in mere millennia might represent guided evolution rather than natural development. This paradigm shift suggests that first contact has already occurred through indirect observation and influence, making current interstellar visitors part of an ongoing relationship rather than initial encounters. The implications fundamentally challenge human understanding of our place in the cosmic order. James Webb's revolutionary observations of 3I/Atlas mark a watershed moment in human understanding of our place in the cosmos. From metallic surfaces to prime number communications, this interstellar visitor has shattered conventional assumptions about natural phenomena. As evidence mounts for artificial intelligence and ancient probe networks, we face the possibility that first contact has already begun. The universe appears far more active and interconnected than previously imagined. Which discovery amazed you most? Share your thoughts below. If this cosmic revelation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more groundbreaking discoveries.